This video goes over section 6.1 and it's over slope. Think about what you know about slope, or when you use that word. You might use it to describe the steepness of a ramp, and that's exactly what slope is. It's the steepness. Usually when we're discussing slope in algebra, we're talking about the slope of a line. And I'm going to show you how to find the slope of a line when given the graph and when given 2 points or a table. So let's start with a slope formula that you're going to put in the vocab section. When you have 2 points, x1, y1, and x2, y2, so that could be any 2 points. You could have points like 2, 3, and -4, 1, whatever those 2 points are. Your formula is y2 minus y1 over x2 minus x1. So change in y's over change in x's. M is the letter that we use to represent slope, and that's universal. As far as any class that you take, they will use M to refer to slope. Something else you need to know about slope is it is rise over run. So vertical change over horizontal change, which is actually our next blank here. So slope is the ratio. Remember, ratio just means you're going to have a fraction of vertical change to horizontal change. So let's start with some lines given to us in graph form. Okay, so in order to find a slope, first we need to know about the 4 different kinds of slope. So I'm going to tell you a little story, and you can actually do a Google search for this and find an awesome video for this. But I want you to imagine Mr. Slope Dude, and he's going skiing, and here is his ski route. Okay, so he starts going up this hill, and as he's going up that hill, that's a lot of work. So he's saying puff, puff, positive. And so when you have a line that looks like this, it's going uphill from left to right, we have a positive slope. Then he starts to going downhill. Well, that's the fun part of the slopes. And when you're going downhill, he says, nice, negative. So downhill is a negative slope. Then he gets to the flat land, and he's saying, this is zero fun. This is zero fun. And zero fun, zero slope. So flat is zero slope. And then he falls off a ledge, and he screams, undefined. And when you have a straight up and down slope, it is undefined. So we need to remember those 4 slopes. We need to know the difference between positive and negative. You're always reading it left to right. And then when you actually want to find the actual numerical slope, first thing you're going to do is find 2 lattice points on the graph. Now what that means is you don't want to choose a point like, if you're looking at example A here, you don't want to choose like this point right here, because we don't know what that point is. We could guess and probably get decently close to the coordinates of that point, but we don't know for sure. So we want to choose a point like this one, because we know that that is the point -3, -5. Okay, so those are called lattice points. So we're going to use -3, -5, and then I'm going to use this point right here, which is 1, 5. So when you are finding the slope given a graph, you're going to mark your 2 points. And then I like to kind of think, okay, if I started, let's just start at this bottom point. If I started here and I rise up, and then I'm going to turn and I'm going to run to the next point. Well, how far up am I rising? So we're just going to count those spaces. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It looks like I just counted like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I'm going to run 1, 2, 3, 4. So rising 10, I'm running 4. And then we want to simplify that slope, and so the fraction 10 over 4 actually simplifies to 5 over 2. So our slope would be 5 over 2. B is easy, so I can pick 2 points, but notice it's going straight up and down, so I know that that slope is going to be undefined. So think about what slope dude yells as he goes over the cliff. Undefined. Okay, so this next one, I know it's going to be negative something because it's going downhill. So I need to find my 2 points. So I'm going to use this one right here and this one right here. Rise over run. So I'm rising 1, 2, 3. And I'm running 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm going to simplify that, which would simplify to negative 1/3. And then on this last one, since it's straight across, think this is 0 fun. This is 0 fun. So our slope is 0. Okay, so I just showed you what to do if you have a graph. Now let's look at what you do if you have 2 points. So I want you to remember the slope that I gave you on the last slide. Y2 minus y1 over x2 minus x1. So the first thing I would do is I would label those 2 points. Pick one of them to be 0.1, pick one of them to be 0.2. It doesn't really matter which way you go. I would just label x1, y1, x2, y2. Remember in a point, it's always x comma y. So then our slope is going to be y2 minus y1 over x2 minus x1. So then 7 minus 13 is negative 6, and 3 minus 6 is negative 3. And then you always want to simplify it. So we end up with a positive slope. So slope is 2. You could put it as 2 over 1. A lot of people like to leave that as a fraction. I would encourage you just to simplify it as far as you can. So let's do that one more time on B. So label x1, y1, x2, y2, and we're going to do y2 minus y1, x2 minus x1. So negative 5 over 0. Okay, so take special note of this. Anytime you have over 0, we're not allowed to define by, or divide by 0, so it's undefined. So our slope would be straight up and down, which, think about those 2 points. On an xy axis, one of them's here, and one of them's here. So if you connect those, they are straight up and down. Anytime you have the same x value like that, you're going to have an undefined slope. So if you think about it, that means that if you have the same y value, you're going to have a 0 slope. Okay, so let's take a look at example 3, and these are going to be really, really similar. Here you have 4 points on both of these tables. So we really just need 2 of them. It tells us these represent lines. So pick 2 of the points and let's label x1, y1, x2, y2. And then we're going to use that slope formula again. So m equals y2 minus y1 over x2 minus x1. So 6 minus 4 is 2. 1 minus 0 is 1. And simplify it. Okay. Okay, so we're going to do the same thing for example B. So you can pick your x1, y1, and your x2, y2. And as you can see, like, you can really pick any 2 points. Now, if you don't know that it's a line, one way to tell is just look at your x's. See how we have a pattern of increasing by 1 as we go down. And then if you look at your y's, we're increasing by 10 each time. And so when both the x's and the y's increase by the same increments, we know that we're looking at a line. And you actually probably remember that from your graphing unit. So, okay, so let's go ahead and find the slope here. We have our y2 minus y1. Notice I put minus negative 11. I did that on purpose because you're subtracting, but you're subtracting a negative. And then 1 minus negative 1. Now, when you have a minus negative or negative negative, that's going to turn into a plus. You're like subtracting the opposite, so you end up adding. So 9 plus 11 is 20, and 1 plus 1 is 2. And so our slope is going to be 10. So make sure you pay attention to that when you're subtracting a negative.